Use dimensional analysis to show that the time taken for an object to fall through a certain height from rest scales like the square root of the height. This is a direct application of the dimensional analysis method that we saw earlier. We will first identify all those factors which we think are likely to affect the time taken. The height, of course, seems to be the most important factor. The higher the place, the longer the time it's going to take for the object to fall down. The mass of the object, intuitively it feels that it has got to be important. And then of course acceleration due to gravity, because that's the reason the object falls down in the first place. We could think of other factors too, right? Air resistance, shape of the object and all that. But for now we are going to assume that it's a point object and so the shape does not matter. And since it's a point object, air resistance also is not going to have much of an effect. So then what we do is we can get this proportionality relation, which says that T is proportional to some power of m times some power of h times some power of g. And since these two quantities are being compared, they need to have the same dimensions. We can write the dimensions on the left hand side as simply T, because there is no m or l. On the right hand side you have m, l, and the dimension of acceleration, which we already saw, is L into T to the power minus 2. By comparing the powers of the corresponding dimensions, we get the values of A, B and C as 0, minus half and half respectively. And so T, by substituting these values in the proportionality relation here, we get T is proportional to square root of h by g, which is the answer we are after, right? We have shown that the time taken scales like the square root of the height.